Hello all, in this video we learn about the pin diagram of 8086 microprocessor. So this is a pin diagram of the processor. It can work in two modes, one is a maximum mode and another one is a minimum mode. So the first pin is called as the ground, the 40th pin is called as the VCC. From pin number 2 till pin number 16, we have the address bus as well as the data bus. So these pins can send and receive both the address related data and the normal data. So we have in pin number 17, we have the non-maskable interrupt NMI. In pin number 18, we have interrupt INTR. We have clock signal in the 19th pin. We have ground again in the 20th pin. In 39th pin, we have the address bus in the data bus. 38 and 37, 36 and 35 pins can both act as a status data. Status signals can access the status signals as well as the address signals. So the 34th pin, it can act that is all, it can act as a BHE as well as a status data. It can handle both the data. So the read signal will be accessed through the 32 pin. Request signal will be accessed through 31. Hold HOLD. Pin number 30 is for hold acknowledgement. Log writing the data will be accessed through 29th pin. Status signals will be accessed through 27th and 28th pin as well as 26th pin. 24 and 25 pins are like address slash enable and interrupt acknowledgement. INTA is nothing but the interest acknowledgement. 23 is for test signals. 21 and 22 ready and reset. So pin number 1 and 20 are for ground signals. Pin number 19 is for the clock signal. VCC is nothing but the power supply where the microprocessor will be handling 5 voltage of power supply. So the reset pin is for refreshing the microprocessor, which is used in pin number 21. As I told already, pin number 2 to 16 will be used as address signals and also address bus and data bus, where the address signals will be traveling and also the data signals will be traveling. Pin number 39 is also the address bus and the data bus. So this particularly contains address bits A0 to A15 when address slash enable is 1 and the data bits are from D15 to D0 when the address slash enable is 0. So the address will be sent when the address slash enable is 1. The data bits will be sent when D0 to D15. D0 to D15 pins will be used for sending the data bits when ALE is 0. When ALE is 1, A0 to A15 pins will be used to send the address bits. So because of that reason only, we are telling that these pins are used for address as well as data. Next one is the address slash enable. When high multiplexed address data bus contains the address information. Next one is a non-maskable interrupt. Next one is an interrupt request. When we are sending an interrupt or when we are connecting a stepper motor to the processor, then we will be using the interrupt request, interrupt acknowledgement. So that's the main purpose of these two. Next one is a hold signal and then is a hold acknowledgement. After receiving the hold or the pause for some time, then the hold acknowledgement will be enabled. So these are like address bus and also the status bus. So address bits A19 to A16 and status bits S3 to S6. S6 logic is 0, S5 indicates condition if flag bits indicate which S4 to S3 indicates which segment is accessed during the current bus cycle. So this is the digital logic for S3 and S4. When it is 0, 0, then extra segment would be functioning. When it is 0, 1, stack segment would be functioning. When it is 1, 0, code or no segment would be functioning. 1, 1, data segment would be functioning. So the next one is a bus high enable or S7. It enables most significant data bits D15 to D8 during a read or write operation. S7 always it would always be 1. So next one is the minimum and the maximum mode. So the minimum mode is plus 5 volt and the maximum mode is 0 volt. So the next one is minimum mode pins, or it's nothing but the data. Maximum mode pins. Maximum mode pins are from 24 to 31. Minimum mode pins are from 24 to 31 in the right side. So the read signal, this one is a read signal, and this one, this one is a read signal. When this is 0, then it would be, the pin would be used for reading the signal. When it is 1, it would be used for writing the signal. Okay, so the WR bar is for writing the signal. M/IO is nothing but memory or input output. DT is data transmit and receive. Data enable. DEN is nothing but data bus enabled or data enabled. So these are the status signals again. The inputs to 8288 to generate the eliminated signals due to the maximum mode. So these three are 3-bit operation. This follows 3-bit operation S0, S1 and S2. The 000 is interrupt acknowledgement. 001 is read input output port. 010 is write input output port. 011 is halt operation. 100 is code access. 101 is read memory. 110 is write memory. 111 is non-passive. These are request and grant. Next one is a lock signal, lock output. This lock output is used to lock the peripherals of the system. So next one is a queue status. So this is also the pin diagram of minimum mode 8086 system. So here it's like the general representation, not the exact one. Here we have interrupt acknowledgement, test signals, non-maskable interrupt, reset, hold signals, hold acknowledgement. VCC we will have clock signals ready. Whatever that we had in the pin diagram, we have this in the mains in this sketch, not in the form of pin diagrams, but as a sketch. I hope you would have found the video to be useful. See you in the next video. Until then, it's bye from Radhika.